Hi, so today I'm going to show you how to write a RoadRunner autonomous along with 3 different ways to add actions for separate motors and servos such as your arm. So firstly in my autonomous here, my first one, I have my package and imports, which you need for sure. Then I'm declaring that this is an autonomous and writing a name for my driver station. Extends linear op mode means my code will go from top to bottom, so it will read my code from top to bottom, line by line. Here I have declared my robot starting pose, which is 0, -60. So in RoadRunner, poses are basically based off of a coordinate plane where X controls left and right and Y controls forward and backwards. So I've started off at -60, 0, -60, so just down. Now map to radians 90 is your heading, so the direction you're facing. I'm facing 90 degrees right now, is what I've written. Declaration of telemetry packet, and here up and down position are just some variables I created for later use. You'll see them later on as like encoder ticks. Here, wait for start, and declaration of start pose, trajectory action builder. So action builder is used here to make a trajectory, so I'm getting that. And here, so I'll show you how to write a trajectory. So trajectories are basically many movements you have. So here, when you write a dot in action follows trajectory, you will find many methods here. So spline 2 is basically a curve. Then you also have line 2. Line 2y means that you're changing your y, but you're keeping the x the same. So you don't need to write your x. You just write line 2y and you write your new y. Line 2x, vice versa. Basically, you just write your x where you change the x, but you don't change the y. And then you have some others here, which are pretty simple to understand based off of this. So for my first trajectory here, I've basically only used spline 2s. So I'm starting at 0, -60, as I've declared before, and I'm going to 0, 0. It means I'm going forward based on a coordinate plane. So I'm going from bottom to top, and I'm keeping my x the same. After I get there, and I'm still facing 90 degrees. After I get there, I'm turning left. So I'm going to -16, 0. I'm keeping the y the same. Then I'm coming back to then I'm going down. So I'm keeping my x the same, but I'm changing my y from -16, from 0 to -60, and I'm keeping the x the same. As you notice here, I have changed my degrees headings. So now for here, I'm facing 180 degrees. So 90, 180, 270, 360. 90 top, 180 left, 270 bottom, and 360 right. And then I'm going back to my original starting coordinates. So here, this code is a simple trajectory to move your robot in a rectangular direction. Rectangle, basically. Then you always have to add dot builds after trajectory, and this basically finalizes your trajectory. Then I'm telling my localizer to get the current pose, and this prevents errors, I think. So, yeah. Then the first method for running separate actions, such as arm motors and encoders, arm motors with encoders and servos, is my example here. So first is elapsed time. You can use time for that. So I'm declaring my timer, and I'm resetting it to 0. So here I wrote that while my op mode is active, so while active is like it's going, and while I'm running my trajectory, elapsed time will run in seconds, and double is like decimals. So here, if my if my elapsed time, so if my time is greater than 1 second, then my arm servo, which is a continuous rotation servo, will have its power set to 1, so it will keep spinning. And my spin servo, which is just a normal servo out of 300 degrees, here I wrote that it will go a total of 230 out of 300. Then I wrote if elapsed time is less than 1, my arm motor will set its target position to up position, which is a variable which I've declared above, which shows my encoder ticks. And I'm telling it to run to that position. I'm telling its mode set to run to that position, and I'm setting the motor power to 1 for it to run to that position. I also have an else if statement for time less than or equal to, greater than or equal to 1, but less than 5. Then I'm setting my motor power from a total of 1 to 0.3 just to hold it in spot. And then after or equal to 5 and less than 8, I'm setting it to down position, which I've also declared above, and I'm telling it to run to that position at a power of half power of total. After all of this, I'm setting my power to 0, and I also have an optional reset over here. Then I basically have telemetry updates showing my time, and I'm updating it every like 10 milliseconds. And yep, that's for autonomous, basically, trajectories and one method. Now, a second method to run my arm here is displacement methods. So here I have the same thing, my action follow trajectory builder, and I have my splines, but instead of a time separately at the bottom, I'm just adding a displacement method during my trajectory. So basically it will run these splines, and after the spline, it has a displacement method. The ds here is the distance. So the distance means that after this action, after 10 inches of this action, do these separate, like do this, yes. So after my robot splines to negative 16, 0, facing 180 degrees, 10 inches of that, after 10 inches of that, you set my arm servo to a power of 1, you set my spin servo position to 230 out of 360, and you set my arm motor to a power of 1. You can add displacement methods anywhere after splines or actions in your trajectory. You don't have to necessarily use splines, but that's what I'm doing. So I have multiple splines over here. So I have more splines, and then I have another displacement method telling my arm servo and spin servo to keep going up. Like, you don't have to redeclare it. I've done it here. I don't know why. But I told my arm motor to set its target position to up position to run to that position at full power. And here, as you've noticed, my distance is now 0. So I've said that after 0 inches, after moving to 0, negative 60 at facing 360 degrees, like straight after that, do this. So this ds here is for inches after doing the action above. Note that based on my experience in testing, I found that the ds is for the action above, not total distance. But yeah, that's displacement methods for the new RoadRunner versions. And that's .build. You have to do that for finalizing. Now the final way for doing separate methods for my arm here, I have an action, and I'm going to do stop and add. So basically over here is a sequential action. So basically at the start, after declaring like my positions and variables, I have created a public action named pickup. And in this action, I basically said that set my arm position to up position, which I've declared right here. And I'm telling it to run to that position at a power of 1, which is full power. I'm also telling it to set my spin servo to 230 degrees at 360, and I'm telling it to set my arm servo to a power of 1, so full power. I'm also telling it to return that my arm motor is busy. So then we go on to my trajectory again, and here I've used line to y, which is basically my starting position here is 0, negative 50. So I basically told it to keep my X position the same, because we're not changing that at all, and that to change my Y position to 0. So go from -50 to 0, so forward. Then I have stop and add, sequential action. So this basically means that stop other movement and whatever action I put inside, execute that. Sequential action means that the action will be running line by line the way I've declared it. So from top to bottom. If I don't put the sequential action, my steps can overlap, but I didn't want that. I want it to do it in this order. That's why I put sequential action, but that is not necessary. You can just do stop and add and the action. You don't need the sequential action. So you do stop and add and then whatever the name of your action is, and then you can continue forward with your trajectory actions. So yeah, that's basically it for my RoadRunner Autonomous explanation here. If you have any questions, let me know in the comment, but otherwise, good. Please keep watching. Thank you.